Hey guys, here we are in lesson 11, still on module 5, and this is video 1. And you can see that we have some quadrilaterals here in our picture. And once again, we are recording them all in units, so we don't have to worry about whether they're meters or centimeters or inches. And you can see we have 1/3 unit by 4/5 unit, 2/3 units by 4/5 units, and that's 3/3. Sorry, it's a little hard to read, by 4/5 units. And here we have the area of each: 4/15 square units, 8/15 square units, and 12/15 square units. So what I want you to do is think about what you notice and wonder here. Maybe share it with someone nearby or write it down. What do you notice and wonder about our rectangles and the areas? One thing that you might notice or wonder is that it's a little sloppily drawn. I just do my best, so that's not what I'm asking you to look at. Just imagine that they are drawn correctly. Maybe you noticed that these are all 4/5. Our lengths are all 4/5, but our widths, our sides, are all increasing 1/3, 2/3, 3/3. Did you notice that? Did you notice that the product of each length and width is equal to the area? The product, remember the answer to a multiplication problem? So 1/3 times 4/5 is 4/15, and 2/3 times 4/5 is 8/15, and 3/3 times 4/5 is 12/15. They all have 15ths because they all have 3 and 5 as the denominator, right? Okay, noticing that? How many rectangle tiles that are 1/3 by 1/5 make up one square unit? So 1/3 by 1/5, right? That would be just one of them. 1/3 by 1/5. And how many of them would make up an entire square unit? 15, right? Because 1/15 of them is 1. And what would the area of one of those rectangular tiles be? Just one of them? 1/15, right? Like we just said. Okay. What if I had a square that was 4/3 by 4/15? Instead of 3/3, if I went up by one more third, and it was 4/3 by 4/5. Sorry, I think I might have said 4/15. Let me get that on the screen for you. 4/3 by 1 by 4/5. How could you find the area of that? Would our pattern continue? Would it be 4/3 times 4/5, which would be 16/15? 4, 8, 12, 16. Do you see a pattern there? If we continue the pattern, we would need to add another unit square that is partitioned into rectangular tiles, and there will be 16, right? Because one, if they're all 15ths, one area squared would just be 15 of them, but we have 16, so we would need to have one more. Does that make sense? Today we're going to be finding the area of rectangles with fraction side lengths, including side lengths that are fractions greater than 1. So you have your little preview there. Okay, let's check out these quadrilaterals. Blank one tricked you. There we go. Let's check out these. Get them to fit on our screen. The top one is 5/3 by 4/5 units. If I just move this up a little bit, we can see it better. There we go. Okay. All right. Hopefully you're looking at that. thinking about it, seeing what you notice there. I shaded 20 parts out of a total of 30 total parts. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 6 times 5 is 30. Does that make sense to you? How many parts are in 1 unit squared? Do you see that there's only 15 here? So is this denominator correct? You are right if you are thinking that it's not correct, right? Because we only use 15ths because that's how many are in 1 unit squared. So instead of 20 30ths, it would be 20 15ths, right? And we can clarify that because we'll think about 5 thirds times 4 fifths equaling 20 15ths as well. Okay, and let's look at one more. This is the same rectangle with 5 thirds and 4 fifths, 5 thirds and 4 fifths, but in this case we tiled just the 5 thirds and 4 fifths without expanding it out into unit squared. And here we have some multiplication. So 1/3 times 1/5. One of these would be 1/15th square unit. And then there's 20 of them. So 20 times 1/15th would be 20 15th square units. A little bit of a different way to look at it. Just like in the last student's work, we would need 3 rows with 5 tiles to tile a unit squared, because 3 times 5 is 15, and each tile would be 1/15th. Multiplying the denominators might always tell us the number of tiles and the area of each tile. So we're just exploring multiplication as a possible way to do this based on what we see in our pictures. Do we see that pattern? And area is equal to length times width when we're working on whole numbers, right? So does that also work for fractions? When we corrected the previous student's work, we found the area of one tile by using the rectangular tile to draw unit squares. Remember that? What did we find as the area of one rectangular tile? One of them was 1/15th, right? Out of a total of 15. Did both methods give us the same area? 20 15ths and 20 15ths, yes? Oh, there we can see them both. We can find the area of one rectangular tile with unit fraction side lengths more than one way. We can use the rectangular tile to draw unit squares or multiply the unit fraction side length of the rectangular tiles. All right. Great job, everybody. I'll see you in video 2. Thanks for your hard work. Aloha.